Greetings and good afternoon everyone. In this video, let us discuss on what is known as Pure Aloha. So basically, Pure Aloha is a fundamental networking protocol used for communication over shared channels. Developed in the 1970s by the University of Hawaii, Pure Aloha was one of the earliest methods for managing data transmission in wireless and wired networks. So, what is it actually? In simple terms, Pure Aloha is a random access protocol where devices transmit data whenever they have something to send, without checking if the channel is free at all. Sounds quite simple, isn't it? Well, let's break it down step by step. Try to imagine a situation where multiple devices, say computers in a network, want to send data. In Pure Aloha, each device transmits its data frame whenever it needs to without any centralized control or checking for ongoing transmissions. If a frame, for example, is transmitted successfully without any interference, all is well. However, if two or more devices transmit at the same time, a collision might occur, leading to data corruption. When this happens, each device waits for a random period before resending its data. This technique is called as backoff, which helps reduce repeated collisions. To summarize how it works, here are the key characteristics of Pure Aloha. Number one, as I said before, no carrier sensing, meaning that devices transmit whenever they have data without checking if the channel is free at all. The second one is collisions can happen. Since there is no control mechanism, multiple devices might send at the same time, causing data loss. The third one is a random retransmission. If a collision occurs, the sender waits for a random time before resending the data, reducing repeated interference. The fourth one is simple but inefficient. Pure Aloha is easy to implement but has a low efficiency due to high chances of collisions. One major drawback of Pure Aloha is its low efficiency. The maximum level of efficiency is only about 18.4%, meaning that out of all transmission attempts, only about 1 in 5 is successful on average. Why so low? Because a frame transmission is vulnerable to collisions in two critical periods. The number one being the time it is actively transmitting, 1T. And the second one, the time immediately before and after the transmission, another T. Thus, the total vulnerable period is 2T, making collisions highly probable. To improve efficiency, slotted Aloha was introduced. The key difference is that slotted Aloha divides time into discrete slots, and devices can only transmit at the beginning of a slot. This reduces the chance of collisions, improving efficiency to about 37%, twice that of Pure Aloha. Despite its low efficiency, Pure Aloha played a crucial role in early wireless communication. Today, it is used in, for example, satellite communication, where simple and uncontrolled access is needed, RFID systems for managing tag responses in warehouse tracking, and basic wireless networks when a simple transmission protocol is sufficient. And to wrap things up, Pure Aloha is an unsynchronized random access protocol that allows devices to transmit data freely, but at the cost of high collision rates and low efficiency. While it's not commonly used in modern high-speed networks, it laid the groundwork for more advanced protocols like slotted Aloha, CSMA, and Wi-Fi. While it had inefficiencies, it laid the foundation for modern networking technologies like Ethernet, Wi-Fi, and mobile networks. Many protocols today, including CSMA-CD using Ethernet and CSMA-CA using Wi-Fi, evolved from Aloha's basic principle. And guys, that is the end of our today's discussion. I hope you guys learned something. And until next time, stay classy. Ciao.